Welcome to today's lesson. We're really going to be beginning lesson 1-3, which is ordering real numbers, but we're going to review classifying real numbers first. So last time we were together, we talked about a Venn diagram and that the Venn diagram and calculators are based on the real number system. Then we said real numbers are broken into two different subgroups, and one of them is irrational numbers. And irrational numbers are basically two kinds: pi and the square root of a non-perfect square. So a non-perfect square would be something like the square root of 24, the square root of 88, square root of 19, and irrational and rational numbers. Now, rational numbers are anything that are fractions and decimals. Anything can be written in the form A over B. So we're talking about fractions and decimals. Within rationals, we have integers. And integers are your positive and negative whole numbers. And inside integers, we have whole numbers. All right, so we're going to classify all of these. So 7/8. When you look at 7/8, that is a fraction. And remember, rational numbers are fractions and decimals. So 7/8 is a rational number, and all numbers are real. So really, I can just go write real by all of these. So the square root of 24, well, that's a square root. So now we have to decide, is that perfect or non-perfect? Well, the square root of 24 is non-perfect, so this is going to be irrational. 0. 0 is your whole number. So whole numbers are going to be 0. So all of them are reals. It's a whole number. And if it's a whole number, that means it's also going to fit in the integers. And it's also going to fit as rational. And we already put down real. So is 0, is that repeating or ending? So this would be a finite or a terminating decimal, and 7/8 is also terminating. So you could also put in terminate in here. All right, 5.45. Well, let's see, we put decimal in here for rational. So this is going to be a rational number. And it is real. All numbers are real. And you can see that repeating part, so we would say that this is repeating. All right, square root of 36. Well, we can actually simplify that. The square root of 36 actually comes out to be the number 6. So if that's the whole number 6, it is not non-perfect. It is perfect. So that means it is going to be whole. It's going to be an integer. It is going to be rational, and all numbers are real. Now this one is also a terminating decimal. Okay, so that's your review of what we did on Friday. All right, what is the new stuff? We're going to be talking about ordering real numbers. So in order to order real numbers, we are going to compare them. And how we compare them is that one of them is typically bigger or smaller than the other one. So we have these symbols that we use. That symbol right there means less than. And this symbol right here means greater than. And of course, we have the symbol that they would actually be equal. So we could give you an expression that they're actually equal. So we're going to be comparing those square roots again. So you guys might want to get out your symbol or your sign. Remember, I had you guys write on a piece of paper your perfect square roots. So we're going to come back and refer to this quite a bit. So this number right here is the whole number 2. So if we're going to say 3, do you see how that has to be less than 2? So let's just say that it is 1.9. Well, 1.9 plus 5 is going to get us 6.9. So let's look at this 5, and the square root of 5 is a little bit bigger than 2. So let's just say it's 2.2. So 2.2 plus 3 is going to get us to be 5.2. So now let's compare 6.9 compared to 5.2, and it looks like 6.9 is bigger, so we're going to put a greater than symbol in there. Okay, so even if this estimate's off a little bit and it's 5.5, if this was 0.5, it's still going to be smaller than that 6.9. All right, next one, the square root of 2 and the square root of 4. Well, let's see, the square root of 4 is 2 plus 2, so this is 4. Well, this side over here is 4 plus something. So whether that's 1.1 or 1.2 or 0.8 or whatever it is, we are adding something to 4, which is going to make this be bigger. And so we are going to put greater than symbol in there again. The greater than symbol. All right. Square root of 12, square root of 6. So if we start with the square root of 4 and we count up, now you guys already have this chart made, so this is going to be super helpful and a lot faster than what I'm doing. So the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So 12 is going to be between 3 and 4, so let's just say it's about 3.5. So 3.5 plus 6 gets us 8.5. And the square root of 6 is right here, it's going to be between 2 and 3, so let's just say that's 2.5. Well, 12 plus 2.5 is 14.5. So the 14 is bigger, so we are going to put this symbol in here so that the bigger end is towards the 14.5. It is pointing, the pointer goes towards the smaller number. All right, okay, now we're going to order things from least to greatest. Well, 4.5, we know that that's 4.5. You guys probably know what pi is. Pi is 3.14, and we're going to add 1 to that. So it looks like we're going to get 4.14. So now the square root of 22, that's between the square root of 16 and the square root of 25. So that's going to be between 4 and 5. So the square root of 22 is going to be roughly, let's see, we have square root of 17, square root of 18, square root of 19, square root of 20, square root of 21, square root of 22, square root of 23. I did not leave myself enough room. Square root of 24. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8 numbers. So 1, 2, 3, 4 right here. This would be your 4.5. 4.5. So is the square root of 22 definitely bigger than that middle 4.5? So when I wrote them all out, it is definitely bigger. So we're going to have to say that's about 4.6 or 4.7. All right, so what do they want? They want the smallest one. Well, what's smaller, 4.6, 4.14, or 4.5? Well, it looks like pi plus 1 is your smallest. Ooh, this first and last one were super close, 4.5 and 4.6. Good thing we found that middle, and we know it's definitely bigger than that 4.5. So 4.5 would be our next number, and the biggest number that we have here is the square root of 22. All right, one more here. So the square root of 5. So let's start with the square root of 1, square root of 2, square root of 3, square root of 4, square root of 5. So this is 1, this is 2. So it looks like the square root of 3 is definitely smaller than the square root of 5. And let's see here, if we're going to go up to the square root of 9, because this would be 3, We have the square root of 6, square root of 7, square root of 8. So what do we have? 1, 2, 3, 4 numbers. This is where 2.5 would be. Is 5 bigger or smaller than 2.5? Well, if this is right in between, looks like 2.5 is going to be our biggest. And then we have the square root of 5, and the square root of 3 must be the smallest. So this, when you're counting, square root of 3 comes before the square root of 5. All right, so we have 3.14 squared. So when we take 3.14 times 3.14, wow, they made these super close. These two decimals would be really, really close. So let's just get rid of that square. What's going to be bigger, pi or 10? Okay, since this is 3.14, now we just have to figure out where the square root of 75 is. What's bigger than that? Well, 10 is the square root of 100. So is the square root of 75 bigger or smaller than the square root of 100? So we're going to go with 3.14, and then our square root of 75, and then our square root of 100. All right, so your assignment is now to open up your book. It's on page 18, or you can look online on your online book, because I'd like for you to do these problems on a piece of paper here. And so I actually just gave you the wrong page number. Good thing I am paying attention today. It's not page 18. We're actually doing page 24. Okay, I apologize for that. So we're opening up your book to page 24. See how I say copy your problem on a piece of paper? So I want you to actually copy it. So the first one says the square root of 3 plus 2. Then they have a circle to compare. And square root of 3 plus 3. Well, these are both the square root of 3, so those are equal. So what's bigger, 2 or 3? Okay, since these are equal, then we're really just comparing 2 and 3. So then we would put this symbol in there. So I want you to copy it, and then so if you can show some work or estimates underneath it. So the second problem is the square root of 11 plus 15 compared to the square root of 8 plus 15. So if we're going to compare, we want to look what the square root of 9, square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15, square root of 16. So this is 3 and this is 4. So the square root of 11 is going to be about, let's just say 3.2. So 3.2, so do you see how I'm showing my work underneath there? That is going to be about 3.2. It might be a little bit, yeah, 3.2. And so now if we add that to 15, we end up with 18.2, but I'm showing my work underneath here. So the square root of 8, even if we say that that's 2.9, it's going to be less than 3 plus 15. So we're at 17.9. So it looks like this is going to definitely be bigger, because the square root of 11 is bigger than the square root of 8. So we're going to make that bigger. All right, good luck on your assignment.